Hey guys, welcome to somewhat of a short note set of note. Oh, I'm purple. I don't want to be purple. I want to be black. So let's try that again. This will be a relatively short set of notes for Math 8A. We're going to move on to lesson 1.7, which is now going to go from relations to functions. Now this should fit on one page comfortably. And we're going to start with a definition, and we're going to use something called a Frere model, and it was created by this guy named Frere, and it basically looks at a vocab word from 4 different perspectives. So I want it to be nice and big, so I'm going to make it take this whole screen. But again, that should be like a third of the page, quarter of the page, about a third of the page, and then we're going to go ahead and do just a little bit more beyond it. So bottom line is we're going to talk about functions today, and they actually relate to relations. So how the Frere model works is that you put the vocab word in the middle, and then you're going to create 4 sections coming out of it. And we're going to put things in those 4 sections. So we're going to be talking about what is the definition of a Frere model. Oops, helps if I spell it correctly, right? What is the definition in the upper left corner? In the upper right corner, we're going to talk about characteristics. And then in the bottom left corner, we're going to talk about examples. And then in the bottom right corner, we're going to talk about non-examples. Okay, so let's go back up to the definition. So what is a function? A function is a relation. So there's some sort of reason why the input matches the output. The x-coordinate belongs with that y-coordinate. There's some reason. So it's a relation where and this is where it gets a little bit more specific, where every input, so every x, every domain, has exactly one output. So that would be your y-coordinate, your range, okay? So this is a little different because we've had relations where we had an input had 2 different outputs. Think about that mapping. So this is saying that might be a relation, but to be a function, every x has to have exactly one unique y. Okay, so let's talk about some characteristics. One of the things that can pass what's called the vertical line test. Okay, so pass a vertical line test. So this means when graphing a function, two points of that function can't form a vertical line. So here's what's weird. You pass the vertical line test if you don't have vertical lines that you could draw through 2 of the points. So it's kind of like you're passing because you fail, but that's what it is. All right, let's talk about examples. So here's an example of a function. Let me draw mini coordinate plane. And most lines, with the exception of vertical lines, would be considered functions because every x has a unique y value. All right. What if I took a set of one of our tables, and we were talking in our notes about a table, and I showed you, I think, a horizontal one or a vertical one, I can't remember which. So 1 pairs with 5, 2 pairs with 6, 3 pairs with 7, 4 pairs with 8. Notice 1 doesn't pair with 2 different y's. 1 only paired with 1 number, 2 only paired with 1 number, 3 only paired with 1 number, 4 only paired with 1 number. Okay? Now this next one might be a little off-putting, but it also is a function. So 1 pairs with 4, 2 pairs with 4, 3 pairs with 4, 4 pairs with 4. Notice 1 only has 1 value it pairs with. 2 only has 1 value it pairs with. 3 has only 1 value it pairs with. 4 has only 1 value it pairs with. Now, let's do a map of this so you can see it clearly. So these are going to be your x's. These are going to be your y's. So we'll do that one in here. So we've got 1, 2, 3, 4. And we have 4 over here. So we have 1 pairs with 4, 2 pairs with 4, 3 pairs with 4, and 4 pairs with 4. This would not be a function if I had 2 arrows coming out of an x value, okay? But I can have them all point at the same y value. It still is going to form a function. What kind? It ends up being a horizontal line, okay? So let's talk about some things that are not functions, so some non-examples. So let's say we have something that curves like this. And then you can see, if I tried the vertical line test, there are 2 points that line passes through on that graph. So this means it's not a function, okay? So we would say it fails the vertical line test. Or, I guess I should say, yeah, it's hard to say. Sometimes I say fail and sometimes I say pass. So I guess if it passes the vertical line test, that you don't have 2 points that form a vertical line. Okay. Well, you can say it from that perspective. So this would fail. So this fails the vertical line test because it forms one. I know that's confusing, isn't it? Okay. Let's look at an ordered pair. Let's do a table. So we'll do x and y. And then we've got 1, 3, 2, 3, 3, 7, and 2, 5. So each x has to have only one y. But look what happens right here. 2 pairs with 3, and 2 also pairs with 5. Okay, so let's take that and let's map it so you can see it. So these are your x's, these are your y's. We have 1, 2, 3, remember we don't repeat. 3, 7, 5, order doesn't matter. And now we're going to connect these. Let's see, 1 pairs to 3, 2 pairs to 3, that's okay. 3 pairs to 7, that's fine. and then 2 pairs to 5. And that's where you have the problem. The 2 has got 2 arrows coming out of it, pointing at a 3 and pointing at a 5. That means it's not a function, okay? So we can, another way to look at this guy over here, the table, would be same domain, different range, different ranges. So that would be not a function, okay? I'm going to go to my next screen because I've filled this one all up, and we're going to just talk about 2 particular types of functions. So this still should be able to fit on the same page. So we're going to talk about discrete function. So again, I'm not titling this because it's still on the same page. And then we're going to compare it to something called a continuous function. Okay. Continuous and discrete. All right, so let me draw you a graph, and then we'll write a couple things about them, and then we'll be done with our notes for today. So a discrete graph looks something like this, or a discrete function. So it's still going to, quote unquote, fail the vertical line test, or pass the vertical line test, meaning I can't draw a vertical line through any 2 points of the graph. So what you're seeing is you see individual dots, which means there's no connecting the dots together. All right, they're just individual points. So you would have here that data, when incremental, that means in between values, don't make sense. This is when we would use a discrete function, okay, or are inappropriate. So again, big point right here. Points are not connected. Okay, so an example of when we would have discrete function is when you were comparing somebody's height to somebody's birthday. Those are 2 distinct numbers, and there's no increments on a birthday. Okay, you're either 12, okay, or the date that you were born is 1 day out of the year. Okay, all right, let's talk about continuous. This is a more common what we see. So let me again draw my graph. I'm going to give you a somewhat uncommon looking graph compared to what you will be seeing throughout this year. Okay, so this continuous graph says data where infinite information, oops, maybe if I could spell correctly today. Is graphed. Okay, so what gives that way that it's infinite is that the arrow caps tell you to continue to go in those 2 directions. So values between data, so graphing points individually. I mean, I could put some points on here, right? But it doesn't just have those points, it has all the points in between them. So values between data are still legitimate values. Meaning they count in this particular situation. So, key thing on this guy is the points are connected. So you can make a flow a line through them, or a curve in this case. So even though this is not one, a good example of a continuous function would be linear equation graphs. So linear means line. Ooh, sorry. So when you're drawing lines, they are continuous functions. All right, so that's what you're going to be working on your practice, is distinguishing if you have a function or just a relation. All right, we'll talk about this on Wednesday. Bye now.